right, here we go. We've got a right triangle right here. Oops, I gotta always forget to change this. No, that is right. Alright, there we go. Alright, we know it's a right triangle only if I tell you it's a right triangle. If it just looks like one, can you assume that it is a right triangle? Of course not. You have to be told that it's a right triangle, and that little box right there tells you it's a right triangle. And we're going to call this side A, call this side B, and this is going to be C. Now we could go through some explanation. If you want to read, if you're really interested in it, you can read. It's on page 26 and 27. They go through this whole thing on how it works. But I'm just gonna show you what the formula is. And you've seen this before, haven't you? You probably saw it. You might have seen it in Algebra 1. I know you saw it in geometry. Yeah. Pythagorean theorem. T-H-E-O-R-E-M. Alright, named after a guy. Anybody know what the guy's name was? Pythagoras. Anybody hear that guy before? Alright, Pythagoras. One of these, I don't know, in my mind, I have no idea if this is true or not, but in my mind I just envision him, walking around the deserts of the Middle East with a robe on and people following him around and him doing all kinds of math stuff, I don't know if that's true or not, but he was, I think, a philosopher. You know how Jesus had 12 disciples and that kind of thing? There's a lot of people back in that day that had disciples. That's kind of how school was. Like there would be one teacher and then people would just follow him around. They'd give up everything they had and follow the person around. And they would teach them all kinds of stuff. Teach them about life, teach them, academics, teach them math, teach them science, teach them astronomy, all that kind of stuff. And I think Pythagoras was one of those guys. He actually didn't come up with this theorem, but he's given credit for it. It's named after him because he was able to have the first good, solid proof on this theorem. And I don't know when he got credit. I don't know the first person that said, okay, let's credit this guy and name it the Pythagorean theorem. I really don't know. You could look it up, right? You've got the world's knowledge at your fingertips. So if you wanted to, you could look it up if you want. But it's named after a guy named Pythagoras. Way back, it was before Christ, I believe. Probably several hundred years before Christ. I've looked him up. I've seen the date. I just can't remember from year to year. I probably should, but I got a terrible memory. Anyway, Pythagorean theorem. Let's do it. These are the two sides. The A and B represent the two sides of the right triangle. And the C is the what? We give this a fancy math name. Right, it's called the hypotenuse. Right, and the A and B always represent the sides of the right triangle. And it doesn't really matter which one you call A or which one you call B. As long as C is the hypotenuse, the A and B are just the other two sides. Everybody got that? All right, so here we go. You've seen this before, haven't you? A squared plus B squared equals C squared. That's kind of a nice, pretty little theorem. Right, nice and compact, ABC, right? It's as easy as ABC. That's how I tell people. And it's pretty simple. Just A squared plus B squared equals C squared. Remember, the C, the hypotenuse, that one's got to be the one that's sitting there by itself. All right, it's the two sides that are squared and added up. So what if you had, we'll make this real easy. What if you had that was 3 and B was 4 and you were supposed to find C? Well, let's put it in the Pythagorean theorem and see what we do. Put a 3 in for the A. Now we have to square it. Don't forget to do that. Don't just add them up. You got to square them for this to work. Put the 4 in there, square that, equals what? C squared. Let's go through it. 9 plus 16 equals C squared. That's 25 equals C squared. How do we get the C by itself? Square root it. Right, that goes away. Take the square root of that. What's the square root of 25? 5. Now technically, the square root of 25 is plus or minus 5. But we don't use the minus version because what are we trying to do? We're trying to find the length of a side. Are you going to have a negative 5 for a length of a side? No, you're going to use the positive version. So just use the plus part of this, all right? So there you go. So C is equal to 5.
Could you have a negative if you went behind the triangle?
No. No, when we talk about the length of a triangle or the distance from this point to this point, it's always going to be positive. All right? Now, when you get into physics, anybody taking physics this year yet? Are you, Judy, you taking it? You the only one? Okay. You're going to talk about vectors. You're going to talk about vectors, and you're going to talk about the difference between displacement and distance. Have you done that yet? And displacement, you do worry about the negatives. The displacement tells you which direction and all that kind of stuff. That's a vector. So negatives do make a difference when you talk about vectors. In this case, we don't care about that. We're only talking about the length of a side. Everybody got that? Okay, so that was pretty easy. And in fact, this is so easy, they give this a special, this is kind of one of our special triangles. This is 3, this is 4, and this is what? 5. In fact, we would call that a 3, 4, 5 triangle. All right, so if I have sides 3 and 4, and that would be, then the hypotenuse would be 5. In fact, if I said, okay, what if one side was 6 and the other side was 8? What do you think the hypotenuse is going to be? 14. Why 14? Just, you didn't add them up. 10, right, because look what you did to the 3. You doubled that, you doubled this, so what are you going to do with that? You're going to double that as well. So you could have a 6, 8, 10 triangle, couldn't you? All right, so that's kind of nice. Watch, if I had, I'll just do this real sloppy. Again, it's not meant to be to scale or anything, but what if I said this was 10 and this was 6, and I asked you to solve for that? You really wouldn't even have to do any real work, would you? I mean, you could throw this into Pythagorean theorem and solve for x, but you could look at it and you say, oh, I got a 6 and I get a 10. Oh, let's see, what goes into both of those? 2 goes into both of those. That's a 3, and that's a 5. So if this is a 3, this must be a what for this to be a 5? A 4. 3, 4, 5, right? Does it make any sense? So this would be a what? A 6, what? 8, 10 triangle. You get it? So that's kind of nice when you have a 3, 4, 5. Look for that. It makes things go a little quicker. When you take the SATs, you know, your college entrance SATs, they'll throw some of those in there. And instead of going through all that work, because it's a time test, right? You have to finish it within a certain amount of time. Recognize that it's a 3, 4, 5 triangle, and you should be able to do that in your head really quick, and then you can move on to the next problem. All right, so look for that kind of stuff. That will show up, I promise you. All right, we good with that? Okay. Let's do another one. Let's pause this, and we'll clean up all this mess. All right, here's another right triangle. Put the little right angle symbol there. Let's just make something up. Let's say this is, I don't know, 5. And let's say this is, let's do this one. Let's say it's like 17. All right, we'll go crazy on this. And we have to solve for this side right here. It's a right triangle. Now, you can only use Pythagorean theorem with right triangles. You can't use this with just any old triangle. You can only use Pythagorean theorem with right triangles, okay? So make sure you do that. That's why I wanted to make sure that you understood that this is a right angle. So let's go through this. What would you do? It's a squared plus b squared, so it's going to be x squared plus, yeah, we'll write it out. I know you can do that in your head, but we'll do it like that, okay? So somebody have a calculator with them? I don't know what 17 squared is off the top of my head. I should know. It's like 289 maybe? No, it couldn't be 9. Yeah, it's probably 289, isn't it? Yep. Yeah. Alright, and then you subtract a 25 from both sides. So subtract a 25. So x squared equals, what's that, 264? Is that right? Alright, then you take the square root, right? Take the square root of both sides. So now there's no way I can do that in my head. What's that? 16.2, that's good enough. 2 what? 2.5, let's go 3 then, okay? We'll round it to one decimal place. Alright, and there you go. If you want to keep it like that, I'd be okay with that. I'd give you credit for that if you just want to keep it like that. A lot of people just like to throw it in a calculator just to get a general idea what this is going to look like. Now, does that make sense that that would be 16.3? Yeah, because this is fairly, this is really small compared to this, alright? Now again, this is not necessarily drawn to scale, so if this is really small compared to this side's got to be quite a bit bigger, and it's, what if you got a number that was bigger than 17? What would that tell you? Then it can't be the answer, because what's always true about the hypotenuse? It's always the biggest side, right? It's always the longest side, all right? So the 17 has to be the longest side. So if you did something in here and you messed up and you got 18 point something or whatever, you got to look at it and say, wait a minute, I did something wrong, and I got to go back and try it again. Make sense? All right. Doesn't get a whole lot harder than that. Now, with that Pythagorean theorem, let's write it like this. Instead of a squared plus b squared, I'm going to write it like this for a reason. C squared equals a squared plus b squared. That's the exact same thing, isn't it? I just switched it around. Now notice, this is equals, isn't it? Now, what's interesting about this, I could tell, if they give me 3 sides of a triangle, I can tell if that triangle's a right triangle or not. And in fact, So if it's a right triangle, what do? If they give you three sides, I take the longest side, and that's going to be which one? Is that going to be the? It's going to be the C, isn't it? I take the longest side and I put it in for the C. Take the other two sides, put it in for the A and the B, and then I see if it works, right? I see if they equal each other. If they equal each other, then guess what kind of a triangle it is? It's a right triangle. Okay, if they don't equal each other, then it's not. It says some other kind of triangle, right? It's not a right triangle. Well, I can actually figure out what other type of triangle it is, okay, by using this. It's not technically the Pythagorean theorem, but it's kind of like it. So watch, if I take c squared and I compare it to the a squared plus the b squared, if that c squared is less than the a squared plus the b squared. Now note, remember what they're doing. They're giving you three sides of the triangle, okay? I take the longest side and I put it right here. I take the other two sides and I put it right here. After I square them, and after I square these and add them up, if this left side is smaller than this right side, then it's an acute triangle. All right, so this would be a right triangle if they equal each other, right? And then it would be an acute triangle. What if that longest side, if I squared it, what if it was greater than the square of the other two sides? Or the sum of the square of the other two sides? What do you think? Wild guess. If you have a right triangle and a acute triangle, what kind of triangle do you think that would be? Obtuse triangle. Good. All right. So that would be an obtuse triangle. It's an ugly triangle. Look. Let's try it again. There we go. All right. So if they're equal, it's a right triangle. If the c squared is less than the a squared plus b squared, it's acute. If it's greater than, then it's obtuse. You with me? Don't just take the c and take the a and the b and add them up and compare them that way. You got to square them. You got to put them into what's kind of like the Pythagorean theorem. Now, technically, this one right here and this one right here with the inequalities, technically is not the Pythagorean theorem, but we'll just call it that anyway. All right. So if the c is less than, or the c squared is less than the a squared plus b squared, it's acute. If it's greater than, it's obtuse. Make sense? Let's do an example. What if they give you sides 7, 5, and 4? And they give you a triangle with those three sides right there. And you have to tell me what kind of triangle is it. Now, you could just guess. You could get a 1 in 3 chance, right, to get it right. But let's get a 100% chance and get it right. So what do? We take the longest side and we square that. So what's that one? 7. Then I take the other two sides. It doesn't matter what order. I square those and add them up. I'm going to leave this blank. Okay, I'm going to put a question mark here because I don't know if it's equal, less than, or greater than until I do the math. Let's figure out what it's going to be. What's that going to be? 49, and that's what? 25 and 16. What's 25 and 16? 41. Yeah. Now compare them. What is 49 to 41? It's greater than, isn't it? So what kind of a triangle is this? It's obtuse. It's pretty easy, isn't it? Yeah. So it's an obtuse triangle. Pretty simple. All right, just make sure you take the longest one, you put that out here on the left-hand side because that has to be the C. Make sense? All right, so make sure you do the longest side first, and then you can do the other two sides of the triangle second. You can tell what kind of triangle it is. All right? That's pretty much it for Pythagorean theorem. That's not too hard, is it? All right, stuff you've seen before, I'm sure. All right, that's it. Let's take a look at some of your homework then.